Good morning, everyone. Today, I'm going to discuss the Unit 3, that is regression. In this, we are going to discuss about what is regression analysis, how we are going to measure the linear relationship between two variables, and determining coefficients and the different types of regression and the metrics for the regression. So, what is this regression analysis? Regression analysis is a statistical method to model the relationship between a dependent and independent variables. That is, that independent variables, maybe it is more than one independent variables. So it is going to show as a linear relationship between dependent variable that generally we represent it as y, and one or more independent variables which we are going to represent it as x. That dependent we can also call it as target variable. Independent variables we can also call it as the predictors. More specifically, why with this regression analysis we do is it helps us to understand how the value of this dependent variable is changing corresponding to the independent variable when other independent variables held fixed. It predicts continuous or real values such as temperature, age, salary, or price, etc. In the last unit, we discussed about two types of data, that is continuous data and the numerical data. So in that, this continuous data is used for the regression analysis, this continuous data. So what do you mean by this? Why we have to do this regression analysis? Let us understand with a small example. Here, there is a small example. Suppose there is a marketing company A who does various advertisement every year and gets sales on that. The below list shows the advertisement made by the company in the last 5 years and the corresponding sales. This is the advertisement and these are the sales. Suppose now in the year 2000, let us suppose say now 2024, okay, let it be 2024. What is the sales as per the previous sales? Now the company wants to do advertisement of for this rupees $200 and wants to know the prediction about the sales for this year. To solve such type of prediction analysis in machine learning, we need regression analysis. Regression is a supervised machine learning technique. It's very important. Regression is a supervised machine learning technique. In the very first class, when we discussed about machine learning, I discussed three types. One is supervised, unsupervised, and semi-supervised. And when we discussed supervised machine learning, I told you there will be two types. One is the classification, one is the regression. Now we are going to discuss in this unit, we are going to discuss about this regression. So regression is a supervised machine learning technique which helps finding the correlation between variables and enables us to predict the continuous output variable based on the one or more predictor variables. That is one or more independent variables. So just remember, what is the outcome of a regression is it will be always the continuous output, not the numerical output. It is a continuous output. It is mainly used for prediction, forecasting, time series analysis, and determining a causal relationship between variables. So what actually we do in regression? What we actually do in regression? Actually, we plot a graph between the variables which best fits the given data points. And using this plot, the machine learning model can make predictions about the data. In simple word, we can say regression shows a line or curve that passes through all the data points and target predictor graph in such a way that the vertical distance between the data points and the regression line is minimum. Let me explain this. We are going to plot a graph showing an independent variable, that is the predictor, and dependent variables, that is target variables. And we are going to draw a straight line relationship, that is linear relationship. And whatever the data, we are going to plot the data points. And when you calculate the actual and predictor, whichever is, when there is a minimum distance between this target and actual, then the regression line should be minimum. That is what the concept behind this regression. See, this is just a diagrammatic representation of a regression that we will discuss in the coming slides. So The distance between these data points and the line tells whether a model has captured a strong relationship or not. So these data points, so the distance between this data point and this straight line gives us a strong relationship or not. There are some terminologies related to this regression analysis. Already we discussed, that is, one is a dependent variable. So which we want to predict or understand is what we call it as a dependent variable, and we can also call it as a target variable. And second one is the independent variable. These are the factors which affects the dependent variables or which are used to predict the values of the dependent variables, and we can also call it as the predictors. And here we call it as the target variable. Outliers. In the last unit also actually we calculated these outliers. Outliers is like it is an observation which contains either very low value or very high value. So and the outlier may hamper the result. So we should avoid this outliers. And there is one more thing, that is multi-collinearity. If the independent variables are highly correlated with each other, then other variables, then such condition is called multi-collinearity. It should not be present in this data set because it creates as a problem while ranking the most affecting variables. So when we are selecting the independent variables now, whichever are highly correlated with other variables, actually we should avoid that one. So that is what this concept of this multi-collinearity. Underfitting and overfitting. The very first unit we discussed the main challenges when we face the challenges. One of the challenges is underfitting and overfitting. So if our algorithm works well with training data set but does not generalize well with the test data set, then such problem we call it as overfitting. And if our algorithm does not perform well even with the training data set, then such problem is called overfitting. So these are some of the terminologies related to the regression analysis. Coming to this types of regression, we have many types of regression. In that, one is the linear regression, one is the logistic regression. So in this unit, we are going to discuss about linear regression. Why? Because linear regression comes under regression technique, whereas this logistic regression comes under the classification technique. So in this unit, we are going only concentrating on this linear regression. A linear regression is a straight line. It shows relationship between two variables, that is x independent variable and the y dependent variable. And you see these dots represents the data points. And the distance between this data point and this line should be as minimum as, then we can say that the prediction is correct. It is best if we get a, when you calculate the model, when it gives us a straight line, our model is the best fit model. That is what the concept behind this linear regression. Linear regression is used for finding linear relationship between target and one or more predictors, that is independent variables x, hence called as the linear regression. Since this linear regression shows the linear relationship, which means it finds how the value of the dependent variable is changing to the value of the independent variable. And coming to these types of linear regression, we have mainly two types. One is simple linear regression. We can also call it as SLR. And one more is multiple linear regression. That is, we can call it as MLR. So simple linear regression and the multiple linear regression. The core idea is to obtain a line that best fits the data. Why we are doing regression is, the core idea is to obtain a line, straight line, that best fits the data. So the best fit line is the one for which total prediction error are as small as possible. Okay, that is, error is the distance between the point to the regression line. So when you see this, whatever the near to this line, the data point, so this distance is as minimum as, we can say that the error is minimum. Coming to this simple linear regression, SLR, is useful for finding the relationship between two continuous variables. One is already we discussed, predictor are independent, and one is the response are dependent variables, or we can also call it as target variable. It looks for statistical relationship, but not deterministic relations. Make a note of this. The simple linear regression or linear regression, it is going to give us statistical but not deterministic. So what do you mean by the statistic or deterministic? Let us discuss that. Relationship between two variables is said to be deterministic if one variable can be accurately expressed by the other. So what it means? So best example, when we are using temperature in degree Celsius, it is possible to accurately predict the Fahrenheit. So whatever temperature in degree Celsius, in the same way accurately we can predict the Fahrenheit. But coming to the statistical relation is not accurate in determining the relationship between two variables. For example, if you ask, as per the height, what is your weight? So no one can give you the exact value. So such type of relationships we call it as the statistical. Why? Because everyone's weight is not dependent on height. If two persons is having the same height, their weight may not be the same. So that comes under this statistical relationship. And coming to this simple linear regression, already told you this simple it is going to give us a straight line relationship. Mathematically, a linear relationship is one that satisfies the equation. You know that it is y equal to mx plus b. So where we know that m equal to slope and b equal to y-intercept. Okay. So, and here x and y are the variables. X is the independent variable and y is the dependent variable. So, with this equation, we are going to find out the straight line relationship between two variables. So, let us assume one data set which contains information about relationship between number of hours studied and marks obtained. Students, it is up to you only how much you study, how many hours you spend on your study, that much GPA you are going to get. So, many students have been observed and their hours of study and grade are recorded. So, just I have collected a small data set where there's the students, number of hours they spent on study and what is the grade. Just we are going to record it on a table. Now, our goal is to design a model that can predict marks if the given number of hours study. So, using the training data, a regression line is obtained which will give minimum error. This linear equation is then used for any new data. So when we calculate, again if I ask you a question, a particular student has studied for 7 hours in a week, then predict what is the GPA. So once you have find out this equation, for the new data, you can easily predict that this is the GPA a particular person is going to get. So if we give number of hours studied by a student as an input, our model should predict their marks with the minimum error. That is what the final goal of a simple linear regression. Okay, for that, the formula already I told you earlier, it is just like y equal to mx plus c. Okay, so here y is the predicted value, that is dependent also you can say. The values b0 is the intercept and b1 is the slope, must be chosen so that we should minimize the error. Okay. So as we discussed earlier, the goal is to find what is the goal of a regression or linear regression is to find the best fit line which can be achieved by minimizing the expression of residual sum of squares, which is equal to the sum of the squares of the residual for each data point in the plot. So residuals, what do you mean by this residual is for any data point is found by subtracting predicted value of dependent variable from actual value of dependent variable. That is, so when you see these residuals, okay, so this is the predicted value. If you take this is the actual value, the distance is the error what we are going to find out. So this residuals with one example, I'll make to practice in the coming sessions. Hope you understood what is a regression, what are the types of regression, and what is the ultimate goal of regression is we have to draw a line that best fits the data. That is what the concept behind regression. And one more point, it is a supervised machine learning technique which is used to predict the continuous variable, which is used for predicting the continuous variable. This is one more important point regarding what is a regression. Thank you.